Let's see the properties of X-rays. First, these are highly penetrating rays and can pass through several materials which are opaque to ordinary light. Second, they ionize the gas through which they pass. While passing through a gas, they knock out electrons from several of the neutral atoms, leaving these atoms with positive charge. Third, they cause fluorescence in several material. A plate coated with barium platinocyanide, zinc sulfide, etc. becomes luminous when exposed to X-rays. Fourth, they affect photographic plates, especially designed for the purpose. Fifth, they are not deflected by electric and magnetic fields, showing that they are not charged particles. Sixth, they show all the properties of the waves except refraction. They show diffraction pattern when passed through a crystal which behaves like a grating. Application of X-rays. X-rays have important and useful applications in surgery, medicine, engineering and studies of crystal structure. First, scientific applications. The diffraction of X-rays at crystals opened new dimension to X-rays crystallography. Various diffraction patterns are used in determining internal structure of crystals. The spacing and disposition of atoms of a crystal can be precisely determined using Bragg's law and lambda equal to 2d sin theta. Second, industrial applications. Since X-rays can penetrate through various materials, they are used in industry to detect defects in metals, structures in big machine, railway track and dredging. X-rays are used to analyze the composition of alloys and pearls. In radiotherapy, X-rays can cause damage to the tissue of body. Cells are ionized and molecules are broken. So X-rays damages the malignant growth like cancer and tumors which are dangerous to life when it used in proper and controlled intestines, controlled intensities. Let's see X-ray absorption. The intensity of X-rays at any point may be defined as the energy falling per second per unit area held perpendicular to the direction of energy flow. The intensity of a X-ray beam decreases during its passage through the sheets of any material. The decrease in the intensity of X-rays is due to the absorption of X-rays by the material. Let I naught be the intensity of incident beam and I be the intensity of beam after penetrating a thickness Z of the material, then I equal to I naught e power minus mu Z, where mu is coefficient of absorption or absorption coefficient of a material. The absorption coefficient depends upon wavelength of X-rays, density of material and atomic number of material. The elements of high atomic mass and high density absorb X-rays to a higher degree. Let's see X-ray diffraction and Bragg's law. X-rays are electromagnetic radiation of low wavelength 0.1 angstrom to 100 angstrom for studying the diffraction pattern of X-rays, we require size of slit equal to or order of the wavelength of X-rays. The spacing of atoms or molecules in crystals is of the order of a few angstrom. Thus, the crystals are used to measure the wavelength of X-rays, just like gratings are used to determine wavelengths of visible radiations. X-rays emanating from X-ray tube pass through two holes into lead screens and then falls on the crystal.